So what we've got here is, it says graph the solutions of this linear inequality 3x plus 12y equals 12. Now, this is no different than what we did for today, except that the equation is not in slope-intercept form. Now, when we started the unit off 3 weeks ago, one of the things we worked on the review day was graphing from this format. And there are two ways you graph inequalities, or graph lines. You either get them to slope-intercept form, or you find the two intercepts. Now, because we've been doing the substitution method, I want to show you, walk you through again, how to take this and turn it into something like that. And then from there, it's exactly what we worked on for today. So I want to get the y isolated, this y by itself. So what do I do to this equation to move everything over to the other side and make the y isolated? Subtract 3x from each side. Right. You start with the outermost layer. Now the other thing I'm going to do when I work on this side of the equation is I want to write it so that it's in this style of the x coming first. Negative 3x plus 12. Not the 2y. 2. Well, it might be what you meant, but not what you said.
Well, if I was to write on my paper,
yeah. Well, that's okay. The other thing to remember, if I divide by a negative, I have to switch this guy around. That's one of those steps a lot of students will forget. Don't be that student. So now I've got y is greater than or equal to negative 3/2 x plus 6. And that's going to be the inequality I graph. And like I said, now from here, it's exactly what we practiced yesterday. If you divide by a negative. Since this guy's positive, I don't. The other thing you guys tend to miss, and I see this a lot, remember both of these have to get divided by the 2. So negative 3 divided by 2 is negative 3/2. 12 divided by 2 is 6. So now when I go to graph this, slope is going to be negative 3/2. And the y-intercept is 6. All right, cool. So there's my axis. I start at 6, so that's up 6 along the y's. So there's my y-axis. 1, 2, 3, 4, 5, 6. And then I follow the slope. Go down 3, and then over 2. So 1, 2, 3, over 2. 1, 2, 3, over 2. So before I draw the line, am I making a solid line or a dotted line? Solid, because it has the line under it. It includes the equal to case. So I make a solid line through there. Something to think about with tomorrow's quiz, if I can't tell if it's a solid or a dotted line, I'm going to assume it's the wrong one. If you're concerned that you're working like with a pen like mine that's a little hard to read, do this. There. Now there's no question you got the right kind of line because you even said, yeah, that's supposed to be solid. Plus the nice thing is if you screw up, you're not scribbling and erasing. Just write dotted so I know you meant to have a dotted line there. Works for me. Shoot. What's up? Hold on. Hold up. Solid lines are when it is greater than equal to or less than equal to. Create solid lines. Without the line underneath. If it's, here's the trick to remember. If there's a line, you draw a line. If there's not, you draw a dotted line. It's like with the solid dot and the open circles. If there's the extra stuff, you put the extra work to bubble it in. The last question we have to ask ourselves now, where's my shading? Is it above it? There's a couple ways to check it. I always use 0, 0 as my test. Guys, so here's 0, 0. And I'm going to go back to the original equation to test it. Is 3 times 0 plus 2 times 0 greater than or equal to 12? Is 0 greater than or equal to 12? No. So that means it's not a solution. So this must be my answer, the other area.
So if it's not a solution, it's a
Right. And remember, an ordered pair is a solution if it makes it a true statement. I'm a little bit nervous because there are some items on the test that go right straight to, here's your inequality, here's an ordered pair, is that a solution or not? So remember the default rule. A solution is any ordered pair that makes that statement true. Or collection of statements true.
Why did you put a question mark in the top?
Because the question now I'm really asking here is 0 greater than or equal to 12? The answer is no. Where did I get what? Where did I get 0, 0 from? That's my test point. You test a point, and I picked 0, 0. You can pick any point you want. 0, 0 is a great test point because it's easy to work with because zeros are easy. They make things 0. If it's not a solution, you shade away from the point. Right. Since 0, 0 happened to be below and it wasn't a solution, I shaded the other side. Now the catch is this. If I had said, let's just for a second, let's shift the line down and pretend that had not been a solution, then I would shade below the line because I shade away from 0, 0. So it's not so much do I shade top or bottom, it's do I shade towards or away from that point. All right, get this back in the view. Can I get the whole problem in there? Yes, I can. Cool.
Record that.
Mm-hmm.